All right, so let's go back to the theory. We have this Hamiltonian then describing a hierarchical triple, which is a situation that is extremely common in nature. It is a function of a perturbing mass, m1, the square of the ratio of the separation between the inner binary and the outer binary, multiplied by the second Legendre polynomial of cosine of psi, which is the angle between the two separations r and r1. To continue, let's substitute the second Legendre polynomial. And remember that the second Legendre polynomial is half of 3x squared minus 1. So now this is the Hamiltonian. We need to find out then what is a form to write the cosine of the angle psi. This turns out to be the most complicated part because this angle is absolutely not trivial. Remember, this is the angle between r1 and r. But because of the dot product, you can also write this as the dot product of r1 over the modulus of r and r1. So the dot product of these two is x1 plus y y1 plus z1 over r times r1. Now, if the orbits are Keplerian, then we have these relations for x over r, y over r, z over r, in terms of the orbital elements. So we can substitute that on the cosine psi. So now let's make the approximation that the outer orbit, the orbit of the body one, is circular and of zero inclination. That's the circular three-body problem. In the case, sine of I is zero, so this last term cuts, but not much else cuts. You can write that the cosine I is equal to 1, so this cancels out. And since the orbit of the outer binary is circular, then we can assume that the longitude of the ascending node is equal to 0, and also the argument of pericenter is equal to 0. So we can get rid of some other quantities here. It simplifies a bit. Also, because the orbit is circular, you can simplify the through anomaly to be equal to the mean anomaly. Therefore, this expression then becomes... Here we can already see why the three-body problem does not conserve energy or angular momentum. As we saw from the Delaunay variables, we have that the angle variables or the mean anomaly associated with the energy, the argument of pericenter associated with angular momentum, and the longitude of the ascending node associated with the z component of the angular momentum. The perturbation Hamiltonian, because of the dependency of this cosine on the mean anomaly of both the primary and the secondary, because of the dependency on the argument of pericenter and the dependency on the longitude of the ascending node, none of these quantities are conserved. Remember, the Hamiltonian equations were for the angle action variables, dh d theta is equal to minus j dot. The Hamiltonian depends on the mean anomaly, it depends on the longitude of the ascending node, and on the argument of perihelion. So none of these actions, energy, angular momentum, and z component of the angular momentum, they're all non-conserved in the three-body problem. That motivates us to find averaged solutions so that some of these quantities end up being conserved. Let's see how we can find that.